Okay, here we go with algebra. This is section 3.2 in the book, if you have one. It's notes 13. It says solving two-step equations. Make sure you put your name, date, and class period. And then your essential question is, how do you solve a two-step equation? And basically how to do that is do the inverse operation twice. Okay, so for our examples here, I double called them so we had plenty of room to write. So it's like the first one. If we're looking at our problem, we have 3x plus 7 equals 19. So as I read it, 3x plus 7. Plus 7 is the last one, so you do that first. Opposite of adding, the inverse is to subtract 7 from each side. So that's where I split it down the middle with the equal sign and I cross it out. That means the 3x drops down. And then I have 19 minus 7 is 12. So that now I'm into a one-step problem that we did yesterday. This is 3 times x. The opposite of multiplying is to divide. So I'm going to put my line and divide by 3 on both sides. That leaves me with x equal to, and 12 divided by 3 is the number 4 as our answer. Okay, if I look at the second example, it has 4y minus 3 on the left side equals 13. And as I read it, I did 4 times y minus 3. Minus 3 is the last thing I said, so that's the first thing I actually have to address. I'm working backwards. So that means minus 3, the inverse of subtracting is to add 3 to both sides. So I'm going to drop my line, split it into the 2 halves so that I can see my new problem. I'm going to bring down the 4y equals, and then 13 plus 3 is 16. If I look at the problem now, it's a one-step operation. This is 4 times y. The opposite of multiplying is to divide. So I'm going to divide both sides by the 4 to cross those out. What's left on the left side is the y equals, and 16 divided by 4 is 4. Alright, the next example has 32 equals 17 minus x. I'm going to put an understood 1 in front of the x, and then because this is actually written backwards, I'm going to move the 32 to the other side and say equals 32, and then I'm going to ignore it on the right hand side. So I rewrote my problem to make it fit a little bit better. Now, if I look at this, I have a 17 minus 1x. 17 is what I have to move first because it's the farthest away from the x. So if the 17 is a positive, I have to make it negative, which is the same thing as subtracting. What drops down is my negative 1x. And then 32 minus 17. I believe that's 15. Yes. That's an equal sign. And now I have to get rid of the negative. This is a multiplication because that's negative 1 times x. The opposite is to divide by negative 1. So that means I have x equals 15 divided by negative 1, which is negative 15. And there's your answer. Alright, here we go with our next example. I have 4a plus 3a equals 63. Notice both of these have an a. So I'm not going to subtract anything. I'm actually going to combine these first because they both have an a. So 4 plus 3 is now 7 a's equals 63. If I'm looking at this, 7 times a, that's a multiplication. So to get rid of 7, I'm going to divide by 7. And I have a equals 63 divided by 7 is what? I believe it's 9. Okay, My next problem is really more complicated. You've got to really focus on what we're doing. If I have 2z divided by 3 minus 7, I'm dealing with my adding and subtracting first, so I need to get rid of the 7. To do so, I have to do the inverse of minus 7, which means I'm going to add 7. Okay, that means I have 2z over 3 is equal to, and negative 9 plus 7 is now negative 2. Now I set it up this fashion so that I can put this over 1. And the reason I'm doing it is because I have a fraction on the left side. I want a fraction on the right side so that now I can do what I'm used to doing, which is cross multiply. Cross multiply. 3 times, I'm multiplying here, 3 times a negative 2 is negative 6. And 1 times 2z is just 2z. This to z is still not by itself, so this is a multiplication, so that means I have to divide by 2 to get rid of the 2's. That leaves me with z equals, here's my answer, z equals, what is negative 6 divided by 3? I'm sorry, negative 6 divided by 2. That would be a negative 3. Okay, if I go to my next example, it has decimals. Okay, on this problem, I have p divided by 3.4 plus 10.4 is equal to 15.4. So I got decimals all over the place. But I'm still going to be dealing with adding, subtracting first. That's my first target. If I look at this, it says adding 10.4. The opposite or the inverse of adding is to subtract 10.4. Alright, so I need to subtract 15.4 minus 10.4. Well, 15.4 minus 10.4, the 0.4's go away, and all I'm left with is the number 5. And since this is p over 3.4, I'm going to put the 5 over a 1 so that now I can do what I did above, and I want to cross multiply. Multiply across the equal sign. So I'm going to do 1 times p, which is 1p, equals, and then 3.4 times 5 is 17. Okay, that multiplication is 17. Now this is a multiplication, so I need to divide by 1 to cancel out the 1's or reduce them, and p is equal to 17 as your answer. Okay, on the back of your notes we have example 3. And it tells me find an input for a function. There's my directions. This is the output of a function is. Here's my word is. That is always my equal. And it says 2 more than 4 times the input. Now think back to our input and outputs. What letter is the input? Our input was the letter X. And our output was the letter y. So if I'm looking at my equation here, I have a y equals, and now it has 2 more than 4 times the x. Now more than means I'm adding, but remember it also tells you that you have to flip your order. So that means I need to do the back end first. 4 times x is written how? 4x. And then I write my plus sign, and what I'm adding to it is the number 2. Alright, here's my equation. The question is find the input when the output is 14. So I'm looking for the input, which is my x. The output, which is my y, is 14. So that tells me y is equal to 14 right there. We'll also know that y is equal to 4x plus 2. So since y equals both of these, I'm going to set these two things equal to each other to solve it. So my equation, I'm going to have 4x plus 2 is equal to 14. Now I'm ready to solve it like what you did on the front page. 4x plus 2. Plus 2 is my last thing. I'm done with my adding, subtracting first. The inverse of adding is subtracting. Okay. That gives me 4x is equal to 14 minus 2, which happens to be 12. This is multiplying 4 times x, so the opposite of multiplying is to divide. The 4's cancel out. I have x is equal to 12 divided by 4, which is 3. Therefore, the input is 3. To answer the question, find the input. The input is 3. Alright, the last example, I'm going to leave that, well, we're going to set it up and then I'll have you solve it as your independent practice. This is similar to the one above. It says the output of the function is 16 less than 5 times the input. The output, once again, the output, I'm going to highlight my important words in there. The output is going to be the letter y. Is my equals. Less than means I'm going to subtract, but I also have to flip. Times, of course, is my multiplying, and the input is going to be my letter x. So when I write this equation, what's it going to be? Y equals, and then right here, flipping means I pull out the back end first, 5 times x, which is just written, 5x, less than means to subtract, and I'm subtracting 16. And it also tells me my output is going to equal 8.5. So to write my equation, put these two things together, and you'll have 5x minus 16 is equal to 8.5. Now I want you to solve this for your independent practice. We'll check it and then make you answer your summary on how do you solve two-step equations.